Hey everybody, this is Larry. This is day 23, 23rd of September for the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. Uh, Today I am very tired. I ran 17 miles earlier today. Decent pace, very bodily just drained. I should be eating more honestly, but it's just one of those things where I don't know. Maybe I need a couple of hours to, and it's already late, so maybe that's not happening to before I could eat a lot. So I'm just drinking uh, the classic Chinese herbal tea, just for calories and some tea. So maybe it keeps me up, which is probably not good, but still. The marathon is in 35 days, so 5 weeks left to go. Am I excited? Yes. But a little bit of a hiccup today. So about 8 miles, or after 8 miles, so mile 9 of my 17-mile run in New York. Well, let's start by saying that I run my runs a little bit in the evening because I don't know. It's a really bad cycle of not going back or not going to sleep early enough. So I run in the evening instead of the morning, and because I run in the evening, I can wake up early enough to do a run. So then I don't know. In any case, as a result of that, I was running on the West Side Highway as people do. But parts of that highway, it's next to the highway, just to be clear. So I'm not like running next to cars directly, and it's very nice. There's no traffic lights and everything, so you just keep running. But today there were certain parts that got really dark, and when I wasn't paying attention too much, there was just uneven asphalt, and I sprained my ankle basically. I rolled my ankle, and then just kind of like the classic ate it. It took me 2 minutes to kind of get up. Like I was just on the ground, crying or whatever. I banged up my knee pretty badly and my elbow. As I'm wearing a hoodie now. There was blood everywhere, bleeding everywhere. My ankle was in terrible pain. So after 2 minutes of that, I don't know. I guess I was just kind of, the obvious question is, okay, do I go home or do I finish this? And I just kind of asked myself, like, who am I? What am I trying to do? Who am I trying to be? And honestly, like a marathon, I don't know. What does it mean? Like, does it mean anything if I finish it or not finish it? I don't know. But in the moment, I just thought, all right, well, let's see what I can do, right? And so in that moment, I kind of jogged for a little bit, and then I kind of jogged a little bit more, and then I just kept going, and then I kind of finished the 17-mile run. Not that fast, honestly. Originally, I was gonna go like basically like an escalating pace. Like I start out a little bit on the slower side and just keep getting faster and faster toward the end. Honestly, I kind of scrapped that and took it a little bit easier until the last like 2 miles, and I was just like, okay, let me try a little bit to see how fast I can go if I really wanted to. I didn't go that fast, honestly, because I also don't want to like push it too much. But still, 17 miles is 17 miles. I'm kind of proud of myself, but I don't know. Honestly, looking back, it does feel a little bit stupid. Because it is like it's like I'm trying to be like David Gorgons or something. Like if I can run tomorrow. I mean, I will see tomorrow how things are here. After I got back, I took off my shoes and everything, and it's swollen. The scrape and the blood is fine. I have first aid kit and stuff like this that I get injured a lot. I even rolled my ankles multiple times before. Maybe not that one though. Usually it's on my other ankle, but it also means that I have a lot of equipment for it. In fact, because I go hiking a lot, as some people might know, I haven't gone that much this year. So, because when I do go, some of my intros are like drone videos. So if you've been watching my channel for a while, you'll actually remember some of that. But when you go on hikes, a lot of things happen. So I actually do have like a lot of things, including ankle braces and stuff like this. So hopefully it'll help me heal in time. And maybe I'll probably have to wear a couple of days just for safety, for support. And hopefully, 35 days to go is marathon. We'll see if I can still, continue to train at the faster pace. If not, that's okay, right? Like, tying it back to Leetcode, right? Remember, it is not the rating that defines you. It's the training that defines you, right? The rating is just one moment in time, one data point, one thing that you're gonna see. But the training never really goes away especially if you actually do it in a way that is not like memorizing it, right? Like or whatever. Like if you train and you actually like to do it, like yeah, maybe you lose some fitness or whatever if you don't do it for a bit, but it comes back very quickly. Yeah, that's what I would say. Don't stress over these things. At the end of the day, you can say it's a marathon, not a sprint. But in any case, that was a very lazy attempt at a pun. But okay, let's take a look at today's problem, 2707, extra characters in a string. Also, happy Sunday. I mean, I guess by now it's like Monday, but hope everyone had a great weekend, by the way. My weekend was mostly good. I slept a lot, and I just been resting all week. I stepped on something. My ankle was a little painful. Yeah, every step hurt, by the way, after mile 9 or whatever it was, after mile 8. So I don't know. It is what it is. But and I know that I keep talking about it, but I can only go straight because my left ankle is the one that votes. I couldn't turn left and put like more weight onto it. It's a mess. Hopefully tomorrow will be better. Anyway, okay, let's actually get to it. All right, go, Larry. Sorry, my apologies. But yeah, I'm actually still in a bit of pain. Maybe I need to take a Tylenol or something. Or maybe a protein shake. Protein shake is good too, right? Anyway, yeah, 2707 extra characters in a string. You're given a 0 index string S in a dictionary of words dictionary. You have to break S into one or more non-overlapping substrings, such that each substring is present in the dictionary. There may be some extra characters in S which are not present in any of the substrings. Return the minimum number of extra characters left over, okay? Let's see. So you have basically a string, and you have these dictionaries, and you can kind of fill it out. And lead goes to right? So okay. I mean, the first thing I would do is kind of look at the constraints. This really looks like shortest path in a DAG problem, right? Or maybe not. I mean, okay, it is a DAG in either case, but it is the shortest path in a DAG. Though usually the way that I say that it implies dynamic programming, but you can actually even do a little bit better, right? I mean, you can maybe even do shortest path, but maybe it doesn't matter in the sense that they will look very alike, honestly. Sorry, I gotta hydrate. I that 17-mile one, I didn't drink that much water. I mean, I did drink, but you just dehydrated for a while, and also some calories. So. Oh, excuse me. All right, but yeah, I mean, I think the thing is that basically you think about that, like if you think about nodes and edges, right? Today maybe I'll be a little bit more elaborate, more detailed. Hang on, I'm pulling up the thing. So I'm always like looking down because under the notepad is where I have my drawing pad, and I always have to find my pen for the drawing pad. That's why I'm always like looking for it. I need to be more organized. Maybe I need to like put it in a thing. But in any case, yeah. And the way that I always introduce these things, I know that people kind of think about these in terms of indexes, right? So if you have like, let's say in this one you say, I don't know, whatever. I'm going to use a new word like, all right. They just say, hello, Larry, right? I know that commonly people like do DP on string. They think about the indexes and stuff, but I think is honestly a lot of the times is much easier if you think about not just the characters. Maybe I'll delete this. Hang on, I wrote it in a really poor way. Not if you don't think about them as characters, but actually as nodes in a shortest path problem, right? And by that I mean not the characters, but actually nodes. The nodes are not the characters, but actually the space between the characters, right? I think once you kind of think about that, and then the indexes is that this is 0, obviously, maybe, hopefully. This is 1, this is 2, right? So forth, dot, 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 you get the idea. And then now the edges are going to be, basically, for example, he is a word. Here's another color real quick. Maybe he is a word. If he is a word, then now you have an edge from here to here. Maybe hello, obviously. Then you have an edge from here to here, right? And these edges, well, we'll talk about that in a sec, right? But that's the idea, and you can maybe add a couple of other words as well, right? Is Ola a word? I don't know. Okay, maybe this is a terrible example, but you get the idea, right? So I'm just going to draw random edges, for example, just for fun, right? And, for each problem, the graph is going to look a little bit different. This is the way that we initially draw the graphs, but there are also other edges that are just like quote unquote implicit edges that in this case you could use to count the extra characters, right? And what I mean by that is that, for example, you have here well, let me say this another way for a second, right? In this case, you can say that this edge costs 0 because, well, it doesn't have any cost to it, right? Where you can draw a second edge that's always going to be next to adjacent characters, but they cost 1 because using this means that we skip the character, and by skipping the character, we leave it as the extra character that the problem talk about, right? So this is 1, this is 1. The other ones are going to be 0, right? I think that's a different shades of green, but whatever. And then the idea here is that you're trying to get from the beginning node to the end node at the cheapest cost. And of course, in this problem, there are a lot of ways to do the shortest path part, but there's also, so that is a thing, of course. But the other thing is that, as it is a string problems, you have to figure out how to calculate these edges, right? These non-implicit edges, and also, so that's 1. Yeah, and so you have to calculate these edges, but also calculate these edges in fast enough time, right? So that's basically the idea behind this problem, the understanding behind this problem, right? And you can probably do this in a couple of ways, but let's see. Okay, so there are going to be 50 words, 50 characters, and 50 length each. That actually allow us to do things kind of cheaply. Because basically, okay, let's say we do a very naive way of creating these edges, right? That's the thing that I want to focus on, because shortest path, like n square, it's a slow way, but, even n cube as a slow shortest path is going to be fast enough because n is 50. So we don't worry about it, or I, for now, don't worry about the shortest path part. We shouldn't optimize it because it's 50, but 50 cube is fast enough, so we don't worry about the shortest path, right? But here, what is the naive way of doing it, right? In terms of comparison. So we have 50 characters, so we can start each word at 50. So that means that, yeah, so it's just going to be 50 times 50 times 50, because basically the idea here is that, yeah, we can do for start as in range of n, right? Where n is length of s, and there are different ways to represent data structures and stuff like this for edges, but for now I'm just going to do a very basic thing, right? But yeah, but then it's just for word in dictionary, right? And then if s and there are a couple of ways you can write this, I think, but yeah, if s of start, or maybe L is equal to length of word, right? If this is equal to word, then there's an edge between start and start plus L, right? So that's basically the idea. And if we do this is going to be 50. It's not n cubed. It just so happens that everything is 50, but it's going to be O of n times O of m, where m is the number of words in the dictionary, times L, because this is a linear comparison, so it's just going to take L, which is also maxed to 50, right? So that's basically the idea behind this. And yeah, and then now we can maybe just, we can say there's an edge between start and start plus L, right? Yeah, we can. How do we want to write it? How do we want to write it? Yeah, maybe we just have a adjacency list. I mean, like I said, it doesn't, and we could even just append L, right? Because maybe you can, figure that out. I mean, yeah, the data representation is not that important as long as you're consistent and you know which one you're choosing and using, right? So then now, after we have an adjacency list, you can now start the shortest path thing, right? So first, range and n. We could do it tops down. We could do it bottoms up. I usually generally write it like bottoms up. So I don't know, but so you can have dp is equal to infinity times n plus 1, keeping in mind that we have n plus 1 nodes if you kind of record the thing, because they're n minus 1 between the characters, and then you have 1 for the beginning and 1 for the end. So it's going to be n minus or n plus 1, sorry. Yeah. And then of course dp of 0 is going to be 0. I don't know why I took so pause. But yeah, and then now here, if dp of, well, maybe not, okay, I don't know why, it shows I. If this is greater than equal to infinity, then we just continue. We could skip it because we don't have to process it. I mean, we don't even need this optimization really because it's n squared and n squared is fine, right? Then now we want to say for L in adjacency list of I, we want to say dp of I plus L is going to be min of, well, just whatever it had before, or dp I, no, I guess just this, right? Because there's no cost. I forgot what I was doing. There's no cost here. And also I'm a little bit, well, I mean, I wouldn't say I'm wrong. This is fine, right? But this would never happen, because what we're going to do is that we also want to update dpi plus 1 is equal to dpi plus 1, right? Well, min of this. We want to minimize this. And of course, one thing that maybe I need to do a DP tutorial on is that it's push or pull DP. I'm not going to get into that much detail, but you can see that from here, we always update I plus 1, so this would never happen, right? So we could just remove it. And that's pretty much it. And then now we can just return DP of n. Yeah, I think one thing that I have to, no, it should be okay. I was going to say we have to make sure that this is within bounds, but I think this implicitly makes it within bounds because it just won't match otherwise. Though you can also like do an if statement, but I think this is fine, even though it's not as precise as it could be. Give it a quick submit. Apparently I did this a while ago. Yeah, and that's pretty much it. Let's go over the complexity really quickly. What did I get a wrong? I mean, I get a wrong answer after the right answer. Huh. Oh, this is, I guess this is during a contest, maybe? What did I get a wrong answer on? Oh, I try to do, I don't know. But apparently I do have a video on this, so yeah. There are a lot of things you can do, but that's what I'm going to end up doing today. Yeah, so what's the complexity here, right? As I said, this is going to be n times m times L, but you can also say, there are different ways of saying it, right? Because, yeah, I don't know. Because you can also say, like, you have a variable, because every word has a different length in theory. So you can say, like, you could define, like, I don't know, another variable for some of the characters, which is maybe slightly more accurate, but maybe not. I don't know. So n times m times L is this part, right? Let me write it down. And in this part, this is O of n times, how many things do we have adjacency list? That's a quick question for you. But I think at the worst case, it can match every word. So that means that this has at most 50 things, right? So that means that it's going to be n times m at the worst case. Yeah, so this is going to be, and in terms of space, I mean, and obviously this gets dominated by the other part, right? By this part. And in terms of space, this thing can actually contain n square space, because you can imagine that, like, and you don't even have to imagine, you could just also try to figure out what the worst case is, right? And one of the worst case, I know that there's distinct things, but as an upper bound, we can play around with non-distinct things. So then maybe it's just, you know, S is equal to all A's, maybe 50 of them, whatever, times 50, maybe not 1 times 50. And then each of the words are going to be, yeah, maybe, I don't know, maybe like 25 or something, but you can also just have a mix, and then you have 50 of these, right? So then that, something like that is about the worst case, and you can imagine that, yeah, each one will be pretty bad. But yeah, and in terms of space, then it's going to match on pretty much every character, so it's going to be about n times m in the adjacency list, which is also another way of saying that each node matches each character, right? So yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Oops. Yeah, I'm not gonna do an extra bomb today. The extra characters aren't going on my foot. I am going to go to bed. Not even to sleep. Just put my leg up and just, you know, do things. But that's all I have for today. Let me know what you think. Thanks for watching. Stay good. Stay healthy to your mental health. I'll see y'all later. Take care. Bye bye.